Okay, does the average Presbyterian donate less than the average Catholic in church on Sundays? Now, in just that first sentence, I got a lot of information. We're dealing with Presbyterians and we're dealing with Catholics. So we're going to have two groups. We're dealing with, let me do this in a different color. We're dealing with averages here. Like I see in the word problem here, I see a lot of averages. So I know we're dealing with means here and not proportions. And then let's do a different color. Let's do blue. I also see the word less than. We're looking for if Presbyterians are less than the average Catholic. So I know I'm going to be doing a left-tailed test. So just from that, I know that I'm going to let mu1 be the group with the Presbyterians, the average for the Presbyterians. And then mu2 is going to be the population average for the Catholics. So let's finish reading this. It says the 9 randomly observed members in the Presbyterian Church donated an average of $27.33 with a standard deviation of 5.52. So what this next section tells me, or this next sentence tells me that for the Presbyterians, the sample size is 9. And from the sample, we get that the average is 27.33 and the standard deviation is 5.52. So that tells me that this standard deviation here, since it's coming from the sample, it is not the population standard deviation. So the mean of the sample for the Presbyterian, so I'll label this average 1, is 27.33. And the standard deviation for the Presbyterian, so that's sample standard deviation 1, that was 552. Okay, now when we go to the next sentence, it says the 9 randomly observed members of the Catholic Church. So that tells me that the second sample from the Catholics has a sample size of 9 as well. And it tells me from those 9 people, the donation had an average of 31.33. So that's the mean of the sample. So that's X bar 2 because it's coming from the second group. And that was 31.33. Now the standard deviation that came from those 9 people from the sample is $6.04. So I'm going to label this as the sample standard deviation from the second group. And this is $6.04. What can be concluded at the alpha level of 0.01? We're going to assume that both populations are normally distributed, and the first average is the donations from the Presbyterian, which we already kind of gathered that from the first section, or the first sentence. Okay, so here's all of our information from the problem. Now, since this is going to be 2 samples, right? I have sample 1 from the Presbyterian, sample 2 from the Catholics. This is either going to be a 2-sample Z-test or a 2-sample T-test because we're dealing with means, right? When we're dealing with means, we look at Z's and T's. Now, because this problem does not give me the population standard deviation and only gives me the standard deviations from the samples, I know that this is going to be a 2-sample T-test. I'm getting lazy and not writing sample in there, but the calculator function should be 2-sample T-test because it's kind of hard to write with this mouse. Okay, so for the drop-down options here, for the null hypothesis, I'm going to put that mu1 is equal to mu2. Right? We're assuming that these 2 averages are going to be the same, but then if someone said, wait a minute, I think it's going to be less than. So we're going to say, is the mean of the Presbyterian less than the mean from the Catholics? So we're going to have mu1 less than mu2 for all our alternative hypothesis. Now, for the test statistics, since we're using a two-sample t-test, my distribution is coming from the t-distribution. So I'm going to use t from this drop-down menu, and now I have to do my calculator work to get the rest of this information. So I preloaded this information in the calculator. I put all my ends, means, and standard deviations into the calculator. So I'm going to go to Stat and over to Test, and I'm going to choose two-sample t-test. So just take a minute and enter in all your information. You want to make sure that you enter the right value in the right notation so that you come up with the correct answer. And then down here for the test, make sure you click left-tailed test, because we're looking at if the average Presbyterian donates less than the average Catholic. So we want to do a left-tailed test. Then we're going to come down here and we're going to choose calculate. And then this is going to give us our T critical and, our test statistic, and then our p-value and our degrees of freedom. These are the big things that you want to check for. And then you can also double check and make sure that your averages and your standard deviations and everything is in here correctly, because it also restates that down here. So let's write this information down. Okay, so I have my test statistic is negative 1.4. Let's see, if we round that to 4 places, that's going to be 666. Okay, now this should come out negative because remember, we're doing a left-tailed test. And if we're doing a left-tailed test and the mean is 0 in the middle, then if we're looking on the left side of 0, we should be looking at negative numbers for our test statistic and our critical values. So this should come out negative. Now for our p-value, when we round it to 4 numbers, we get 0.0810. This number, because it's the p-value, meaning it's a probability, should always come out to a number between 0 and 1. If you get a number that looks like it's not between 0 and 1, most likely you're looking at a number that's written in scientific notation. Look for that capital E that signifies that you need to move your decimal place. If it's a negative, you want to move it to the left, however many places it says. So if it says some number and then E -5, then you want to make sure that you move your decimal place 5 places to the left. So make sure that this p-value is always between 0 and 1. Now, for the critical value for the rejection region, we want to find on our distribution graph where the cutoff point is using our level of significance. So my level of significance for this problem says that, let's see, it's 0.01. So my rejection region is going to be here in the shaded red area. And because we're using a level of 0.01, I want this shaded area to be 0.01. So because also we are using a t-distribution, we're going to have to use inverse t to find this cutoff point right here. And that's our critical value so that we get a shaded area to the left of 0.01. Now, when we're dealing with the t-distribution, we have degrees of freedom. So from the calculator, I'm going to write down our degrees of freedom. So in this case, it's 15.87205. So I'm going to write this down. Degrees of freedom is 15.87205, and then 351. Now, when you're doing a two-sample t-test, there is a complicated formula to find this number. So instead of using that complicated formula, you can just get the information off the calculator. If you are enthusiastic and you get excited about formulas, you can definitely look that formula up online and see if you can get the right answer. But for most of you, I suggest just getting it off your calculator to save yourself that stress of the nasty formula. Okay, so now I'm going to go ahead and do inverse t. So I'm going to hit second and then the bars button and find my inverse t. My area that I'm going to use is 0.01. I want that area to the left, and my degrees of freedom is 15.87205351. And I get that my critical value is negative 2. Let's see, if we round that to 4 places, that's 5858. So let's put that down for my critical value. That's going to be t is equal to negative 2.5858. Now, again, this should be negative because we're looking at this left-tailed task, which is to the left of 0. So I have negative 2.5858. That's my cutoff point. So that's my T critical. Now, to use this to make a decision, we want to look at our test statistic and see if it falls in the rejection region in the shaded red area, or if it doesn't fall in there. So we're looking at this graph as a number line. 0 is on the right and negative 2.5858 is on the left because it's less than 0. So now when I look at my critical value of negative 1.4666, let me do this in a different color. I'll do purple. That number, the negative 1.4666, falls between 0 and the negative 2.5858. That falls in here somewhere. That's my test statistic. Because it's not in the shaded area for the rejection region, we are not going to reject the null hypothesis. So I'm going to choose failed to reject. Then in step 4, when I use my p-value to make a decision, if I look at my p-value is 0.0810. And that's greater than alpha. So when you have a p-value that's greater than alpha, you do not reject the null hypothesis. So I choose that again, and these should always match up. So when I state my final conclusion, since we are not going to reject the null hypothesis, I would say there is not sufficient evidence to conclude that the population mean amount of money that the Presbyterians donate is less than the population mean for the Catholics. So I would choose this one here.